A common way to implement the disjoint set abstract data type is via the uptree data structure. Basically, an uptree is a graph in which every single element is one node in the graph, and some nodes are just regular nodes, and some nodes are sentinel nodes. Sentinel nodes. So every single set is represented by its sentinel node, which is the root of that specific tree. So in this example, I have 3 sentinel nodes, which I'll be coloring in pink, and I have 2 non-sentinel nodes, which I'll be coloring as orange. And just to reiterate, every single node in this graph is an element in my collection. But the sets are represented as the trees, and they're specifically represented by each tree's root or sentinel node. So every node only has one pointer, which is a parent pointer. And this way, basically, I have to be able to implement the 2 key operations, right? I have to be able to implement find, which I can implement by just return the elements sentinel node. So if you asked me what set does B belong to, I could go up parent pointers until I reached A, and I would say B belongs to set A. If you asked me what set does A belong to, I would traverse up parent pointers. Oh, I don't have to go up any parent pointers because my parent pointer is null. And I would say A is part of set A. D is part of set C. C is part of set C. E is part of set E. So given any node, so any element corresponds to a node, given any element and therefore its node, I can tell you what set it belongs to by just traversing up parent pointers and returning the sentinel. And then for union, I can find the element sentinel nodes and make one the child of the other. So for example, if I wanted to do a union operation on E and B, I would find B's sentinel node, which is A, just using the regular find operation. I would find E's sentinel node, which is just node E, again using the regular find operation. And I would make one of these the child of the other. So specifically, let's say I was doing union on B and E. What would that look like? I would find B's sentinel node, which is A. I would find E's sentinel node, which is E, and I would make one of them the child of the other one. Arbitrarily, I'll just make E become a child of A. So how would that look like? This would result in, so I'm just going to separate this out a little bit. So this would result in A, who still has B as a child, so B's parent pointer is pointing to A, but then now E is also a child of A. So I'm setting E's parent pointer, which was originally null, or it just wasn't pointing to anything. I'm now going to set it to point to A. So E's parent pointer was null, but now it's pointing to A. And the rest is unchanged. C is another sentinel node, and D is a non-sentinel node whose parent is C. So this would be the result of doing union BE. I took one of the sentinel nodes, in this case specifically I took E's sentinel node, which was E, and I made it a child of the other sentinel node. Regardless of how you choose to make one node the parent of the other, both ways will make a correct uptree. One thing I want to emphasize is that nodes can have multiple children, right? We're not representing child pointers. Every node has a parent pointer, and multiple, specifically any number of nodes, could point to the same sentinel node, or can generally point to the same node as its parent. For example, I could theoretically have an uptree where I have A, and then maybe I have B pointing to A, so B is a child of A. I could have C also pointing to A, I could maybe have D still point to C. So D's parent is still C, and then maybe E is also pointing to A. This would be a theoretically valid uptree as well, where everything is in the same set, and that set is set A. So if I asked what is the set that B belongs to, I would traverse up parent pointers, A. What is the set that D belongs to? I would go parent, parent. Oh, I'm at a sentinel node, A. So in general, I can have multiple nodes pointing to the exact same parent node, and nodes that are not sentinels can have parents that are also not sentinels. Both situations are fine in an uptree.